Good morning, my name is mvohra. I am Managing Director at Advanced Silicons and MV Mobility Limited. We are manufacturer of cushioning materials and furnishing products for railways and other mass transit applications. Welcome to this video on the subject of cushioning material, in which we have tried to cover the various important features of a cushioning material and their significance, specifically being used in rail vehicles and other mass transit applications. This video is not meant for any kind of sales promotion. This is just an attempt to extend our technical assistance to our customers, designers and mass transit sector. And we hope that you will find it helpful in designing best quality chair car seats and sleeper berths for a comfortable and safe journey of the passengers. Cushioning material is important. It is important because this is the main interface between the vehicle and the passenger throughout the journey. Yes, the passenger remains in contact with only one material throughout the journey, and that is cushioning material. This is the importance of the material. And when you say that you strive to offer the comfort to the passengers, then you essentially have to focus on the quality of cushioning material. Like any other material being used in transportation sector, cushioning material also has two set of parameters or properties. Number one, you can see, is the performance parameters. Performance parameters are the primary intent of this material. Now, main intent of this material is to be being used in the vehicles to offer comfortable journey to the passengers. So, in case we are not able to do so, then the objective of using this material is completely defeated. Hence, at least any of these 1, 2, 3, 4, 5, any of these 5 parameters cannot be altered, irrespective of the nature of the material. We cannot say that we are using a material X, then the value of these parameters will be different than if you use a material Y. The values has to be standardized, and it should be made applicable for all type of materials, as I said once again, irrespective of nature of the material. Now, the performance parameters which you see here are actually interlinked with each other. None of these parameters, any one out of 5, it is not possible to understand one parameter in isolation. All of them have to be collectively understood, and then we can easily understand the concept of performance of cushioning material or comfort of cushioning material or the life of the material. And as you see, the number 2 are the safety parameters. These are linked with safety of passengers. Hence, just like performance parameters, even these cannot be altered, irrespective of the nature of the material. We cannot say that if you are using X material, then the values of these parameters will be different than if you use Y material. The values have to be standardized once again, because it is linked to safety of the passenger. Then let us start with performance parameters, and let us start with indentation hardness. Indentation hardness is simply the force required to compress the material by a particular percentage. We can say indentation hardness at the rate 25% compression. So, simply it is the force required to compress the material by 25% of its thickness. So, whenever we use the term indentation hardness, we should always mention the percentage elongation or percentage compression along with it. It is not right to say that lower indentation or higher indentation, never say that. We should always say indentation at the rate X percent, the way it is written, indentation hardness at the rate 25%, indentation hardness at the rate 40%. This is the complete sentence. And now we see household sofa sets. If you talk about, we see that the value of indentation hardness at 25% compression is very low. But on the other sides, if you see indentation hardness at the rate 25% compression for rail vehicles, mass transit applications. So, there the value is comparatively very high. So, does that mean the lower value of indentation hardness is more comfortable in sofa sets and higher value of indentation hardness is more comfortable in trains? No, absolutely not. Lower value of indentation hardness at the rate 25% or 40% compression always give better cushioning effect. I repeat, lower value of indentation hardness, it gives better cushioning effect. Then why do we use high value of indentation hardness at the rate 25% compression in high occupancy applications like trains or buses or things like that? It is because indentation hardness of the material and its compression set, that is the life of the material, both of them are interlinked. Lower indentation hardness of the material will result in faster compression set or faster sagging, or the life of the material goes down drastically. So, you take a particular material, say polyurethane foam, and let us say you produce that foam with 5 kgf indentation at the rate 25% compression, and then you prepare maybe another foam and you prepare with the same material polyurethane foam with at 10 kgf indentation at the rate 25% compression. We see that the foam with the lower indentation will sag faster. You can see that. On the left hand side, it is 5 kgf indentation at the rate 25% compression. On the right hand side, it is higher indentation. So, the lower indentation form sag faster. So, that means lower life. That means more maintenance cost. That means we have to shell out more money in maintaining this particular material. This is the reason the suppliers and sometimes the designers tend to specify the higher indentation, so that the burden of replacement is lesser. But on the negative side, this is done at the expense of discomfort to the passengers. So, what is really speciality of a good cushioning material? What is a good cushioning material? We would say that the most premium cushioning material is the one that offers long service life even at lower indentation hardness like 10 kgf at the rate 25% compression. This is possible only when the material used are inherently free from compression set. And this property of the material is used free from compression set. This property, this is used as an opportunity to extend best in class comfort along with the longest service life. And here is the chart which shows that the optimum value of indentation hardness for different applications. There can be 10% variations in the values going by different regions, going by different suppliers, but more or less you will find these are the reasonably good values. These are being used in the industry. So, if you see bed pillows, very low indentation hardness. So, these are most comfortable, we know that. Back pillows slightly higher, household sofa set slightly higher. And if you talk about things like railways and mass transit application, this is even more firmer than this step. So, this is thin seat cushions and firm mattresses. So, 15 to 20 kgf hardness. And in case you disagree or there is a confusion specifying the correct indentation hardness at 25% compression, the technique of pressure mapping can be used. This is a pressure mapping mat. This has about 1024 sensor installed in it, and it works on a simple principle. A good cushioning material is the one in which when you sit on it or you apply load on it, the pressure will be distributed all over the surface of the material. Say for instance, this is the cushioning material. You sit over it or you apply a load over it. The load should get spread over all the surface of the area. So, at one point there will be very, very minimal load, right. So, the pressure on your body or on your veins gets reduced. Also, it is important that it remains same during the course of the journey. Should not be the fact that we just sit over the cushion and then it is comfortable, and over a period of 10-15 minutes it becomes harder or the value changes, things like that. Softer and cellular materials distribute the pressure much more effectively than the harder material. Take an example. When you sit on a wooden chair, it is very hard. Does this distribute pressure across its surface? No. So, in pressure mapping, a special mat which I showed you with more than 1000 sensors is used. A cushion to be tested is placed below this mat. So, we take a cushion and then we place a matting on top of it, and then we take a mannequin of an average human weight, and it is made to laid on this particular cushion or it is made to sit on this mat for the duration of the journey of a train or a bus. And if this material is hard, then you will notice that gradually the pressure on the parts of the body that are in contact with the cushioning material start increasing, and that is how it causes discomfort. And you can see this is the sitting posture of pressure mapping and this is the laid portion of the pressure mapping. So, red spots shown here means there is an excessive pressure on the veins. So, there it will affect your blood circulation, and here also a little bit. So, in case you take a harder material or in case the material is very hard, the pressure builds up immediately and start affecting the blood circulation in the veins and causes discomfort. In case we have frequent long journeys, so we have health issues. So, it is important that try to negotiate the lowest possible indentation hardness at the rate 25% compression with your suppliers, but without reducing the warranty period, not affecting the life of the material. On the other side, does that mean the value of indentation hardness at the rate 65% compression should also be lowest? No. If that happens, then the material will not support the body. The value of indentation hardness at the rate 65% compression should be highest possible, so that the upper 25% thickness of the material provides cushioning and the bottom 35% thickness of the material supports the body, and this is called comfort factor. This is the ratio of indentation hardness at the rate 65% compression and indentation hardness at the rate 25% compression. Obviously, higher the comfort factor, higher the comfort to the passengers. So, you should aim at higher indentation at the rate 65%, but lowest possible indentation at the rate 25%. I hope you understand. Compression set is an accelerated test method to test the life of the material. If a supplier claims lower indentation hardness and long service life, then it can easily be ascertained or verified by this technique. Take a small specimen, maybe 50 mm by 50 mm of a cushioning material. Keep this in compression stage by 50% and keep this at 70 degrees centigrade for 22 hours, about a day and night. So, this is how the oven looks like, in which 70 degrees centigrade temperature is maintained, and you can see the specimen and the plates. So, you can use these plates to compress the specimen by 50%. So, sometimes you see some suppliers claim or challenge that 70° centigrade is a high temperature and never happens inside the trains or buses. But please note that this is an accelerated life test, and this is possible only with higher temperature. And this is specifically determined in the relevant test method like IS 7888. Rather, sometimes the rail operators demands for 100° centigrade at the rate 22 hours. So after this test, the thickness of the material should not be reduced by more than 10% of its thickness. And in case it gets compressed or it remain compressed, it doesn't come back, it remains at 50% thickness, then it is not a good material to be used. There will be life related issues, there will be maintenance related issues for sure. So let us summarize here. What is an ideal cushioning material now? This is the one which has lowest indentation hardness at the rate 25% compression. This is the one which has lowest compression set, so that it offers same performance after 2 months, after 2 years and after 10 years of service. And for that matter, even a fatigue test can be used. A fatigue test is used. The performance of the new cushioning material is checked, and then it is compressed by a roller shown here, a roller, and this is how the specimen looks like, about 350 mm by 350 mm. And it is subjected to about 20,000 to and fro cycles after compressing it by 50%. And after completion of this test, the same performance is checked once again. This test is also helpful in determining the performance of the material after a particular period and use. Sometimes the rail operators demand for 100,000, means 1 lakh cycles, to check the consistency for a longer use and duration. So it should have, as I said, after that, the highest indentation hardness. A good cushioning material should have the highest indentation hardness at the rate 65% compression, and obviously it will have a higher comfort factor, higher value of comfort factor. No need of determining a good value for 65% compression. If you have a highest comfort factor, it can be derived only when you have higher 65% indentation hardness. Now we come to safety parameters, very important parameters. As we know that the evacuation time in the running vehicles, especially the running trains, can be very high. So while we are selecting the fire and safety parameters, we need to consider number 1, the time required for the train to come to stop from 160 km/h or 200 km/h to 0. That is the braking time. In that event, the train cannot stop at any bridge or a tunnel or any point where the passengers cannot deboard. That you have to keep in mind. And then every coach has about 70 passengers, sometimes more also, and not all of them are young. The time required to evacuate the last passenger from the coach has to be again kept in mind. So the total evacuation time can run as high as 30 minutes sometimes. Even if it is a day train, you will agree that especially the day trains today, which are being designed, runs at high speeds as high as 160 km/h. So you can imagine the braking time it will take, and then so obviously the deboarding time. In that event, the smoke toxicity is taken as the most critical factor. By past experiences, we know that the majority of the fatalities or deaths in the fire accidents that has happened, it has happened because of poisonous smoke that emits when the material burns. Smoke toxicity. Smoke toxicity is the measure of, or you can say the degree of poisonous in the smoke that is emitted when the materials burn. There are numerous toxic gases that are identified by the scientists over a period of maybe 5 to 7 decades. that can bring immediate fatality. You can see the list of these gases here, and you can see these are about 14 gases, and you can see the CF value. The CF value of each gas is also mentioned here. Now, as a layman, you can consider that lower the CF value of the gas means more poisonous gas, and higher CF like carbon dioxide, it is relatively a very less fatal gas. So, take carbon dioxide CO2 as an example, wherein we have a CF value of 100,000, 1 lakh, and the next gas, immediate next gas is carbon monoxide, that has CF value of 4,000. Immediately 25 times more. You can simply mean that it is 25 times more poisonous or more toxic than carbon dioxide. And then you can see the list. The most poisonous or the most toxic gas is phosgene, 4,000 times more poisonous than carbon dioxide, only CF of 25. You can see the severity. Now, there are few other popular test methods that are used to find the toxicity index of the material. The first one is NCD 1409. This is a British naval standard. Then we have EN 45545, or you can say this works on ISO 5659. This is a European Railways standard. You have BS 6853, recently got inactive. You have BSS 7239. This is an aerospace standard. Now, you can see in NCD 1409, you have a list of all these 14 gases that has to be detected. However, in EN 45545 standard, you can see that they detect only 8 gases out of it. So, hydrogen sulfide, ammonia, formaldehyde, acrylonitrile, phenol, and phosgene, they are not detected, even though they are very toxic, very severe, but still they are not detected. Now, this is the decision of an engineering department or the safety department of the regulatory authorities, that which standard is more suitable to them. In case you see that there is a possibility of emission of formaldehyde gas, ammonia gas, and maybe the most toxic phosgene gas, when these materials installed in the trains are burned, then obviously the standard NCD 1409 has to be adopted. If you are sure that the materials used in the train are such that they will never emit formaldehyde, they will never emit ammonia, acrylonitrile, phosgene, phenol, hydrogen sulfide, then you can safely adopt EN 45545. Because sometimes there is a clear mandate to the suppliers that they will not use elements like sulfur, they will not use elements like nitrogen, benzene, etc. in their materials. Then it is obvious that these gases will not be emitted. And further, if you are sure that even hydrogen bromide or hydrogen cyanide shall not be emitted, then maybe you can adopt a standard like BSS, which is Boeing standard, aerospace standard 7239. We have to keep one important thing in mind, that it is a well established fact that toxicity index, when tested as per NCD 1409, I repeat it once again, when tested as per NCD 1409, and when only 100 gram of material is burnt in a volume of 1 cubic meter, it brings the death of a person in 30 minutes, average person in 30 minutes. And we know that the cushioning material installed in the trains are much more than 100 grams. It sometimes ran into 600 kgs or sometimes 1 ton something. If the toxicity index of the material used is much higher, I repeat, as per NCD 1409, this is the philosophy we are adopting. it is much higher than 1, then the survival times comes down drastically. And that is why in some past fire accidents, we have seen that the passengers were fatal within 1 to 2 minutes of inhalation of toxic smoke. So please be careful while adopting the method. And please remember that this definition of 30-minute survival period was established based on the toxicity derived by NCD 1409 test method. Please do not use the toxicity index by any other method while you are calculating the survival period of the passengers. To cite an example, let me see here. We tested our silicon foam cushioning material in 2 prominent laboratories, and here are the test reports. The first test was conducted as per EN 45545 in German Railways laboratory, their government laboratory, Bahn it is known as. You can see the toxicity index of the material. Our silicon foam cushioning material came as 0.02. The same material, when tested as per NCD 1409 at another prominent laboratory, Central Power Research Institute, Bangalore, the toxicity index was 0.4484. And here we have detected only 2 gases were detected, carbon dioxide and carbon monoxide, no other gases are detected in both the reports. So 22 times more. So never say that toxicity index as per EN 45545 is only 0.02, so that survival time is much more than 30 minutes. Because EN 45545 smoke toxicity test method is very, very dilute compared to NCD 1409. And in case you still have doubt, then choose any material in which you have smoke toxicity test report available for EN 45545 and get the same material tested as per NCD 1409. Just a 2-hour test to get the report, and you can easily compare. Following are the 2 competent laboratories in India to conduct the test of NCD 1409 for accurate and consistent results. Or the advice can be sought from the learned engineers of CEN Senelec Center. This is headquarters at Brussels, and they are the regulators of EN 45545. That why these 6 fatal gases are not considered in their test of toxicity, because emissions of formaldehyde, acrylonitrile and hydrogen sulfide are very common in the materials that we use in our railways, or maybe international railways as well. And we can take their advice, their good advice. Probably they can share their experience with us. Also, sometimes we say that people in the day trains are vigilant, so we can be lenient in selecting a test method. Please see that the speed of the day trains are being designed today touches 200 km/h, and calculate the braking time and calculate the time of the evacuation of the last passenger. It can be aged women or children, and then adopt a suitable test method or evacuation time accordingly. Now, another important difference between these 2 test methods is NCD 1409, it is tested, the materials are burned using 1150 degree centigrade flame. However, EN 45545 test method, in which the temperature of 600 degree centigrade is used. Consider a normal candle flame. You can see at different parts of the candle flame, we usually see a temperature of 1000 degree centigrade, at one part 1200 degree centigrade. Only the wick temperature is 350 degree centigrade, except wick all are above 1000 degrees, 1200 degree centigrade. So when with a small candle flame we have a temperatures running above 1000 degree, is it not good to maybe test the materials by burning them at more than 1000 degree centigrade, which is there in NCD 1409. Probably some of the materials may disintegrate into gases, or emission of gases is even higher at higher temperature. So this is about toxicity, and the next important one is ignitability. This is another important factor. It is important to test that how fast the material ignites when it is subjected to burning. The most widely used test for the same is ISO 4589. That tests the amount of oxygen which is required to support the burning of material. Generally, our air has 21% oxygen, and if the material requires much higher percentage of oxygen in the air for burning, the material will be superior. So it is usually advised to keep this index as minimum of 32% oxygen, irrespective of the nature of the material used. And this is how it is shown. It is done in this kind of equipment. It is shown here. And then it is important to understand if the material used is burned, then at what speed will the flame be spread. A test method advised by International Union of Railways is UIC 564. Here we take a specimen, small specimen of 150 mm by 50 mm and 13 mm thickness, and use a 30 mm, 38 mm blue flame. Blue flame is higher in temperature, and the application time is 60 seconds. Here the proposed value is class A, and dripping is not allowed, and once you remove the flame, the extinction time has to be less than 10 seconds. And then heat released by burning materials again causes a big injury to the passenger. So the materials that releases higher heat on burning should not be used. This test is conducted in a cone calorimeter equipment using a 25 kilowatt flame, and the relevant test method is ISO 5660. And then subsequently, when the materials burn, it emits very high smoke, different levels of smoke, different degrees of smoke. The visibility goes down, and in the event of fire, it becomes difficult for passengers to see which side to go for evacuation. It is essential that we keep a check on quantity of some of the emissions from a burning material, and the relevant test method as advised by International Union of Railways is UIC 564. And if you have the history of fire accidents, then class A is essential. So all the safety parameters that essentially has to be common irrespective of the nature of the material. We cannot say that if we are using material X, then we use specifically flammability of class A, but if you are using material Y, then we specify a flammability of class B. We hope that this session will be useful to you and help you in selection of right materials for your applications. Thank you very much. Have a comfortable and safe journey. Thank you very much.